Good morning, students. Okay, today we are going to continue the topic carbon compounds. Its continued topic is covalent bond. Yesterday we have discussed about the basics of carbon, what is the importance of organic chemistry in our daily life. Apart from that, we have discussed about that some part of carbon and all the information regarding the unique features of carbon. Today we'll go with the covalent bond. Yes, in the earlier classes, we have studied about the ionic bond. Today, we are going to discuss about the covalent bond. Ionic bond, where the transfer of electrons was taking place. And if you go with this covalent bond, in this covalent bond, difference is there. What difference is there? Sharing of electrons will be there. Sharing of electrons. Ionic bond, transfer of electron from metal to non-metal, but covalent bond will take place in between the non-metals only. Sharing of electrons will take place. Sharing of electron between the two same atoms or two different atoms. Yes, here it is a sharing of electron between the same atoms or different atoms. If you write oxygen as O2, if you remember it, oxygen, magnesium reacts with oxygen to form magnesium oxide. Okay, O2 will write it. If you take about the carbon, carbon reacts with oxygen to form carbon. We write carbon as only C. Okay. If you take about the phosphorus or sulfur, if you remember in the class 9, phosphorus will write it as P4, phosphorus 4. Or if you remember as one more part, that is sulfur, yes, 8, sulfur octaatomic, phosphorus tetraatomic, carbon monoatomic, oxygen diatomic. Apart from oxygen, we will write even the hydrogen, nitrogen. Yes, these all are considered as monoatomic. It is only carbon is here monoatomic. These all are diatomic. Nitrogen, hydrogen, and oxygen. We'll write as H2 plus O2. H2, it is here H2 because hydrogen is sharing an electron between the one more hydrogen. O2 will write it as oxygen is sharing electron between one more oxygen atom. N2, nitrogen sharing with the nitrogen, and four electron between each other. 4 phosphorus. Sulfur 2 are sharing to get octet structure. These all are there. Carbon mono is nothing, there is no change here. Nothing there, nothing sharing here. It will share with the other elements. Carbon will share with the carbon will share with the oxygen, carbon will share with the phosphorus, carbon will share with the hydrogen, carbon will share with the nitrogen. Yes, lot of chemicals are there in with the carbon because carbon is monatomic, phosphorus tetratomic, sulfur octatomic, or it is also called as polyatomic. Here, sharing of electron between the same atoms, different atoms. If you go the different atoms, HCl, hydrochloric acid, or hydrogen chloride, we will use the word hydrogen chloride here, or CH4, methane. CH4 is methane. C4, H10. Yes, C4H10 is butane. Butane is used in the LPG. CH4 used in the CNG, compressed liquefied natural gas. LPG, liquefied natural gas. Hydrogen chloride. Okay. NS3. NS3 is ammonia. NS3 ammonia. Or you can take it as H2O. Yes, these all are there, but we have to discuss only about carbon atoms, carbon and its compounds. Okay, we'll start with it. First, we'll discuss about the sharing of electron between these all chemicals. Sharing will be there because non-metals, metal, if you go with the ionic bond, where the metal is able to donate electron, non-metal receive the electron. But if you go with the covalent bond, none of the element donate the electron. These all are receiving electrons. Nitrogen, hydrogen, oxygen, carbon, phosphorus, sulfur. They all receive electron. Where the carbon share the electron. When they join with each other now, they share electrons because these all are having less number of electrons in the outermost orbit. Or excess electrons are there, highly impossible to donate. So what they will do it, they will share the electrons. For example, oxygen. Oxygen 2 6 is its electronic configuration. Or if you take over the hydrogen is 1, nitrogen is 2 and 5. I am writing the electronic configuration of all the elements. Phosphorus 2, 3, 2, 8, 5. Or chlorine 2, 8, 7. Chlorine needs only one electron to become octet. 7 plus 1 to become 8. 8 in the outermost orbit. Oxygen, it needs 2 electrons to become octet. Hydrogen, it needs 1 electron to become duplet. Only duplet it is here. These are octet. Nitrogen needs 3 octet and phosphorus needs 3 electrons to become 8. Is all the electrons to become 8 in the outermost orbit or 2 in the outermost to become duplet or octet? Even if you see about the if you ionic bond also, the all the electrons or all the atoms to become duplet or octet, they were donating electron, they were receiving electron, but these are sharing of electrons, that is a covalent bond. Everyone is a receiver only, so they will share electron between both of them to become octet. How it is formed? In the ionic bond, one was donating, that is metal, and non-metal was receiving. That was okay. But here, the sharing of electron will takes place. Now we'll discuss about that how this sharing of electrons will be there between the same atom or between the different atoms. Even here also we are having the Levy structure, or it is also called as electron dot structure of different chemicals. Okay, starting with these chemicals about the hydrogen, oxygen, nitrogen, how they are sharing the electron between both of them. Okay, Before going for these all sharing of electrons, we'll go for one more type. Difference between covalent bond and ionic bond. Difference between covalent compounds and ionic compounds, because bond is directly I should told about it. Bond is there in the ionic bond is transfer of electron between the metal and non-metal. Here sharing of electron. If you take about the ionic bond, it was between the metal and non-metal. Covalent bond, it is between the metals and between the non-metals. About the compounds, first point, if you take about the ionic compound, and covalent compound, 4 points are there. So same thing, ionic compounds, these are solid state and these are hard in nature. Cone compound, these are available solid also, liquid also, gas also. These are available in the all the states, and these are soft in nature, except carbon, that is diamond, graphite, fullerene, coal, except those all things are soft. I'm talking about the compounds actually. Compounds all are, if you take about only compounds, these are soft. If you talk about only compounds, these are soft in nature. Liquid state and gaseous state. Liquid and gaseous state, these are soft in nature. Yes, solid state is there automatically hard in nature. If the material is hard, automatically its melting point and boiling point will be high. Melting point and boiling point is high in the ionic compounds. Here, melting point and boiling point is low. Melting point and boiling point is low. Third is they can dissolve in water. They cannot dissolve in, for example, petroleum, crude oil, it will not dissolve in the water. If you see about the petrol or kerosene, it will float on the water. Yes, they will not dissolve at all. What about sodium chloride? It will dissolve in water. If you stir for a long time also, these organic compounds, those covalent compounds, they never dissolve in the water, but these will dissolve in the water. Sodium chloride, just stirring for hardly 5 or 10 seconds, it starts to dissolve in the water. Okay, fourth one, they can conduct electricity in molten state. Yes, ionic compounds conduct electricity in the fused or molten state, but they cannot conduct electricity. Yes, they cannot conduct electricity in the molten state because already they are in the molten state. Melted only cannot conduct electricity, but these can conduct electricity in the fused state or molten state. Okay, ionic compound Yes, these all are hard in nature and these are available in solid state. Covalent compounds, these are soft in nature, liquid and gas state. These are available in the liquid as well as in gas state. Ionic compound melting point and boiling point is high because the materials are very hard. Automatically melting point and boiling point is very high. But covalent compound, yesterday when I told about some of the materials, acetic acid is liquid state in the room temperature. But here these all are, or methane is gaseous state in the room temperature. Its melting point is below the room temperature. Boiling point is also below the room temperature. So those melting point and boiling point is very high, very low. If you take about here the compounds of here, for example, sodium chloride. Sodium chloride, it melts at very high temperature. Boiling still more high temperature is needed. Okay. Ionic compound they dissolve in water. Covalent compound it does not dissolve in the cannot dissolve in the water. Last the fourth is ionic compound can conduct electricity in the molten state or fused state, but covalent compound they cannot conduct electricity in the fused state. Okay, these are the differences of ionic compound and covalent compound. And what about the bonds? Bonds. Ionic bond it is a transfer of electrons and covalent bond sharing of electrons. Just now wrote it here, sharing of electrons. Ionic compound and if you take about the ionic bond will takes place between the metal and the non-metal. Covalent bond takes place between the non-metal and the non-metal because and everything is same because they want to become stable. What is stable? To get the to attain the stable electronic configuration. Nothing but to attain the 2 or 8 in the outermost orbit as a duplet or octet in the outermost orbit. They are donating electron, they are receiving electron, or they are sharing the electrons. Okay, this is about the difference of ionic compound and covalent compound. So now we will start the next part, how the electrons are sharing between themselves only. Okay, we'll go with the next part that is sharing of electron. Starts with the hydrogen. Okay, hydrogen hydrogen its atomic number is 1 and its electronic configuration is 1. Okay, hydrogen is having one electron in the outermost orbit. Electronic configuration is 1, atomic number is 1. Automatically, electron will also be 1. Now, what happens? I'll use two different pens to show that what are those two difference in the two electrons. Okay, this is hydrogen. The first hydrogen having one electron. This is about the second hydrogen. Only to show the difference of the sharing electron, I am using two different color pens. This hydrogen is having one electron. This hydrogen is having one electron. As see here, if I close this part, this hydrogen is having two electrons in its area. In this margin, two electrons are there. It shows that this hydrogen has become now two electrons. And if I close this hydrogen is having two electrons for it. They are sharing. It is not donating or it is not receiving. It is not donating or it is not receiving. Two hydrogen are there between the two hydrogen. Now what has become hydrogen from one electron? This hydrogen has become two electron. Yes, this hydrogen has attained stability. And if I close this hydrogen was having one electron and now it has become two electron by sharing its electron with this hydrogen. It is sharing its electron with this hydrogen, electron of this hydrogen. So even this hydrogen has become duplet structure, two electrons. This hydrogen has become duplet. And if I open this and if I close this electrons, yes, even this hydrogen has become duplet structure. Okay, both the hydrogen has become duplet structure, and in between the two hydrogen there are two electrons. Two electrons are sharing. So between the two electrons are equal to one bond. Two electrons, one bond, four electrons, two bond, six electrons, three bond, and eight electrons, four bond. Eight electrons, maximum octet structure. Eight electrons, maximum is four bonds will be there, that is octet structure. Yes, between the two hydrogen, there is a single bond, and always there should be a single bond for the hydrogen whenever it is sharing an electron. I repeat, always there should be a single bond for the hydrogen whenever it is bonding with any of the atom of the element. If it is bonding with the carbon also, it should have only one bond only, one electron from its side. Okay, then two electrons are there, two electrons are sharing, one bond is there. So it is also called as or write as H2. Yes, H between sharing between two H is also called as H2. Now got the idea why it is H2. Second, we'll go with the oxygen. S oxygen atomic number is 8. The atomic number of oxygen is 8. Its electronic configuration is 2,6. Electronic configuration is 2, 6. Okay, two electrons are needed for this oxygen. Two electrons are needed for this oxygen. Now, sharing of electron between two oxygen. I repeat, just I am showing the two different colors of pen only to show that how these are different. Okay, this is oxygen number one. This is oxygen number two. Both oxygen are there. Outermost orbit of oxygen is having 6 electrons. Outermost orbit of oxygen is having 6 electrons, or outermost shell or orbit, 6 electrons. And this oxygen, 6 electrons means actually it needs only two more electrons to become octet. 6 plus 2 will become 8. So 2 electrons will share here. 4. Already 1, 2, 3, 4. Already they are in the pair. 5 and 6 are there now. 6 electrons are there in this line. It is of this oxygen. And if you take about this oxygen it is also having even 4 are in the pairs and 2 are unpaired. This oxygen is also having 6 electrons in its outermost orbit. So now if I close this part of the oxygen, this oxygen is having 4 electrons outside and 4 electrons as a sharing. Sharing are there because this line is there. Sharing are there. 4 electrons are there. 4 plus 4 is 8. This oxygen has shared 2 electrons of this one more. This oxygen has become 8 electrons, that is octet structure. And if I close this oxygen has become 4 plus 4 electrons, that is 8 electrons in its outermost orbit. Even this oxygen has become stable. Both the oxygen has become octet structure, both has become stable. So now it is between the two oxygen, oxygen 1, oxygen 2. There are 4 electrons, 1, 2. I told it 4 electrons are equal to 2 bond or double bond, or it is also called as O2. We'll write as the word H2 or O2. Remember it. H2 is here now. O2 is here now. Yes, always we should use double bond wherever the oxygen is there. But use double bond wherever the oxygen is there. So this is about the O2. H2, O2. Single bond between the two hydrogen atoms and the two oxygen atoms. Whenever oxygen is bonding with the one more non-metal, compulsory oxygen will go for the double bond. Hydrogen always goes with the single bond. Single bond, 2 electrons. See, by sharing 2 electrons, it has become octet because already 4 are in the pair, 2 are unpaired, 2 more need to become pair. 4 are unpaired, 4 are paired, 2 pairs are there. 4 are paired, 2 are unpaired, 2 more to become pair, 8 electrons. 4 plus 4 will become 8, 4 plus 4 will become 8. This is about the duplet structure, this is about the octet structure. 8 electrons in the outermost orbit, 2 electrons in the outermost orbit. So it has become duplet, it has become octet. S O double bond O or O2 or H single bond H means hydrogen always should have single bond, oxygen always should have double bond. Okay, this is about the hydrogen and oxygen. We'll go for the one more chemical, that is triple bond now. Now we are discussing about the sharing of electron between the same atoms. We'll discuss the different atoms later on. Now the nitrogen atomic number is electronic configuration of nitrogen is 2, 5. Yes, here 5 plus 3 will makes it as 8 here. 5 plus 3 will makes it 8 here. So it need 3 electrons. Means it need 3 electrons means it has to share 3 electrons. It has to share 3 electrons. It shows that 2 are paired and 3 are unpaired electrons. Okay. Now, with nitrogen, this is about the second nitrogen. I told that we are having 5 electrons in the outermost orbit. For this nitrogen, 1, 2 electrons are already paired, 3 are unpaired. 1, 2, 3. About this nitrogen, 2 electrons are unpaired, 2 electrons are paired, and 3 are unpaired. Okay. Now 6 electrons are there to share. 3 of this nitrogen, 3 of this nitrogen. Okay. 3 pairs of nitrogen are sharing nitrogen and nitrogen. 6 electrons are there. 6 electrons means 3 bonds, triple bond. This line is called as a bond. Okay. This line is called as a bond. We need S nitrogen is having this nitrogen and this nitrogen is having 6 electrons to share 3 bond. S nitrogen will become or it forms triple bond between both the nitrogens, or it is also called as N2. Yes, we are having single bond, double bond, triple bond. Tetra bond is a bit different. Single bond is over for the hydrogens, a double bond was with the oxygen, and a triple bond with the nitrogen. The P4 and S8. We are discussing about the sharing of electron between same atom. Between different atom, I think so we will discuss in the tomorrow. Today we'll discuss about the P4 and S8. P4, phosphorus 4. Okay. P4 is bit typical phosphorus 4. What we studied, how the arrangement will be there. Bit different will be there P4 actually. It will not at all link with in this way. No circles and all those things. Bit different will be there P4. Like a reverse kite type. Reverse kite type. I'll show that. Phosphorus. Phosphorus atomic number is 15. Its electronic configuration is 285. Phosphorus electronic configuration is 285. are there in the outermost orbit and it needs three more electrons to become octet structure. Now, bit different will be there, it will not be like a circle shape. I show you put different way. Four different phosphorus with four different colors of pens. Starting with the first phosphorus, five electrons are there in the outermost orbit. Out of five electrons, the same way, two are unpaired. Two are paired, three are unpaired. Two are paired, three are unpaired. What is this paired? If you see here, phosphorus, one electron, two electron, three electron, four electron. Fifth will be paired here. If you see here, fifth will be, this is paired, these three are unpaired, paired and unpaired. So I am using the word paired and unpaired because these are most important here. Why I will try show here in this way. If you go for the 11th, that they will get a new theory. It is called as VSEPR. I repeat, VSEPR. Valence shell electron pair repulsion. Valence shell electron pair repulsion. This pairing is important. Pair. So now I'm using the word pair and unpair here. So one more theory will be there. Molecular orbital theory. These all are having some exceptions. Those what you are going to learn in the 11 and 12. 11 only I think so. It is for the class 11. Okay. Now we'll go with the phosphorus. Five electrons are there in the five electrons outermost orbit. Two electrons are paired, three are unpaired. We'll start with the first phosphorus. Yes, this phosphorus, two paired, three unpaired. Two are paired, three are unpaired. Okay. Now it's about the first phosphorus. Second phosphorus. I showed here exactly down of it. Two are paired, three are unpaired. Two are paired, three are unpaired. Now, here phosphorus number three unpaired, two are paired. And fourth phosphorus will be here, two are paired, three are unpaired. These are the four phosphorus. Now I'll show the how it takes the bonding. Yes, see here, this phosphorus, three are there. It needs three more, three electrons are sharing to become octet. One is here, sixth, seventh, okay, eighth. This is about the first phosphorus. And go with the second phosphorus with the black. This phosphorus is having 2 plus 4, 2 plus 3 is there, 5, sixth is already paired, seventh will be here, eighth will be here. Okay. Now this phosphorus is having 1, 2, 2 are paired, 4, 3, 4, 3, 4, 5, 6 is here, seventh is here, eighth will be here. Yes, this is about the P4. How it looks, top, bottom at a triangle like a cone shape. Same. Top as at the same point and three electrons will be there in this way. Triangle shape. This way, triangle shape will be there. The first phosphorus, second phosphorus, and fourth phosphorus. Phosphorus 1, 2, 3, 4, and they all are interconnected. Those all the phosphorus are interconnected, so it is called as P4. Called as P4. Triple bond is there between the all the phosphorus, because if you go with this phosphorus, three bonds, this phosphorus, one, two, three bonds, this phosphorus, one bond here, one bond here, one bond here, this phosphorus, one bond here, two bond here, three bond here. Triple bond is there. Because all the four phosphorus, it is P4, bit different from all everything here. This is about the P4 structure. The last video today we will discuss about that S8 structure. Sulfur 8, that is octatomic. It was a tetratomic. Sulfur was considered as octatomic, what you have studied in the class 9. We continue the topic, that is S8. Now is sulfur atomic number is 16, electronic configuration is 2, 8, 6. 6 electrons are there in the outermost orbit. It needs 2 more electrons, because it needs 2 more electrons. So sulfur 1, sulfur 2, sulfur 3, sulfur 4, sulfur 5, sulfur 6, sulfur 7, sulfur 8. Okay, each sulfur is having 6 electrons. Pair I'll show as a dot, unpaired I'll show as X mark. Bit I'm changing here. Paired I'm showing as, I'm showing here X mark. Paired 2 are there, unpaired X is there. Yes, paired here. Those which are top, no, I'm showing at the side as X mark. Those which are side, top or bottom, I'll show the X mark, that is pairing at the side, and for the left and right side, I'll show the sharing at top point, top and bottom point here, X mark here. Okay, students, now all the sulfur are having 6 electrons, where 4 are paired, 2 are unpaired. Now these unpaired, now this sulfur is this sulfur has 6, 7. This for this sulfur, 7th is here, 8th is here. Yes, next one. This sulfur has become 6, 7th is here, 8th is here. This sulfur 7, 6, 7, 8. This sulfur 6, 7th is here, 8th is here. This sulfur 6 are here, 7th is shared here, 8th is shared here. This sulfur 6 are here, 7th is here, 8th is here. This sulfur 6 are here, 7th is shared here, 8th is shared here. This sulfur 6 are here, 2, 4, 6, 7th is here, and 8th will be shared here. This sulfur 6 are here, 7th is shared here, 8th is here. This is about the S8 structure. S8. Yes, this is about the sharing of electrons same atoms. Tomorrow we are going to discuss about the sharing of electron between the different atoms. Okay. Okay. Thank you, students. We'll discuss the topic in the next class. Thank you to all and all.